Hi everyone, welcome back to another video. Today we're going to be looking at chemical equilibrium. Let's take a look at this question, which reads, the reaction of carbon monoxide with oxygen as investigated, or is investigated rather. The reaction reaches equilibrium in a closed container at constant temperature T. They give us the reaction and they tell us that delta H is less than 0. Changes to the conditions of equilibrium are made at different times. The graph shows the results obtained. X, Y, and Z represent the gases in the above reaction. All right, now we can see that on our x-axis we have different time intervals, T1, T2, T3, with some changes happening at each interval. On our y-axis we have concentration, so we are measuring the change in the concentration as time passes. The question reads, use the graph to answer the question. So at T1, oxygen was added to the container. Write down the letter that represents O2. Choose from X, Y, or Z. All right, so at T1, right here, we are looking for, so if something is added, we are looking for a sharp spike. All right, now the one that has a sharp spike is X. And the reason why you would get a sharp spike is because something is added. There is an immediate increase in its concentration. Okay, so the answer to that O2 is going to be X. So that's going to be my graph for O2. Next question reads, at T2, the pressure is adjusted by changing the volume of the container. Was the pressure increased or decreased? Okay, now at T2, let's just make a note of what's happening. So at T2, I can see on this graph or on these graphs that, okay, there's a decrease in these concentrations. Okay, so there's a decrease in the concentration. So nothing I can read too much into it that much or so far. However, afterward, there's some changes, and that's what we should focus on here. We'll notice, and let's just track the oxygen graph because we know it's oxygen. So oxygen decreased sharply and then it had a gradual increase. Right? It had a gradual increase, which means that if I wrote this reaction, 2CO plus O2 gives me 2CO2. Since the oxygen curve is increasing, it means that the side that oxygen on was favored. In other words, it means that the reverse reaction is favored. Now we need to work backward now, right? So why would the reverse reaction be favored? Or what does the reverse reaction represent? Now when we talk about pressure, we talk about the number of molecules. Okay? Now the reverse reaction represents more molecules. Remember, this side has 3 molecules, this side only has 2 molecules. So in other words, we can say that if the reverse reaction was favored, it means that the side with more molecules was favored. Now, why would the side with more molecules be favored? Well, it must be if the pressure was decreased. So the answer here is that the pressure was decreased. Now let's go step by step through Le Chatelier's principle to make sure that our answer is correct. If the pressure is decreased, the system would want to increase the pressure. How would the system increase the pressure? By favoring the side that has more molecules. In this case, the reverse reaction will be favored because the reverse reaction had more molecules. And so O2 would increase. But not only O2, there's also another molecule that would also increase, CO. Now, we can do two things at once here. If we look at our graphs, we can see that there is another graph that also increased. So Z must be CO. So Z must be CO. And then by process of elimination, it means that Y must be CO2. Again, why am I saying this? I'm saying because since the reverse reaction was favored, the concentration of O2 and CO would increase. Since we know that X is O2, it must mean that Z is CO, since we can see that the concentration increased. Okay, 6.1.5, write down the name or formula of the gas that is represented by Z. Okay, we've answered that. Give a reason, we've answered that. 6.1.7, what change in temperature is made at T3? Choose between increased or decreased. Okay, now let's look at what happened. At T3, I can see that CO2 increased. CO2 increased. Now, CO2, let me write the reaction one more time. So CO plus O2 gives me 2CO2. And now when we talk about temperature, we need to look at the delta H. The delta H was less than 0. Now, since we can see clearly that the concentration of CO2 increased, it means that the forward reaction was favored. And the forward reaction is exothermic. And the only time an exothermic reaction will be favored is if the temperature is decreased. Right? If the temperature is decreased, then the exothermic reaction will be favored. So the answer here, since the exothermic reaction is favored, it means that the temperature must have decreased. Okay? Use Le Chatelier's principle to explain the answer. We can say a decrease in temperature favors the exothermic reaction. The exothermic reaction is the forward reaction. The forward reaction is therefore favored. Right? That means the concentration of CO2 will increase and the concentration of O2 and CO will decrease. And that's exactly what we observe if you look at those other two curves, they decrease. Okay, let's move on. Now we have our 9-mark KC question. Okay, and the question reads, carbon monoxide gas reacts with water vapor at T degrees Celsius. The reaction reaches chemical equilibrium according to the balanced equation. Initially, 0.6 moles of CO, 0.6 moles of H2O, 0.1 moles of carbon dioxide, and 0.1 moles of hydrogen were mixed and sealed in a 2 dm cubed flask. If the equilibrium constant for this reaction is 4, calculate the mass of CO present in the flask at equilibrium. Okay, now with any KC question, you can get a lot of marks just by constructing the table and filling in certain values. Now the table is a rice table. I mentioned this in previous videos, you can watch them. So what we'll do is we'll construct this rice table. R, I, C, E. Now, R stands for ratio, I is initial, C is change, and E is equilibrium. Okay? Now, let's write out our reaction here. So CO, then H2O, then CO2, then H2. Now I'm going to draw a double line here to separate reactants and products, and then let's just neaten up this table. Now when we talk about ratio, we are talking about the coefficients of these compounds. Now in the balanced reaction they give us, you can see that it's all 1 to 1 to 1. So simple here, the ratio is 1 to 1 to 1 to 1. Now initial represents how much how much was added at the beginning. So at the beginning they tell us you have 0.6 moles of CO, you have 0.6 moles of H2O, you have 0.1 moles of CO2, and you have 0.1 moles of of H2. Then they tell us the Kc value. Okay, or they also tell us the volume. So let's write here volume is 2 dm cubed. Okay, next we look at the Kc. Now the Kc, remember, is equal to the concentration of products divided by the concentration of reactants. And the exponents would be the coefficients. So Kc is going to equal the concentration of H2. The coefficient is 1, so we don't need to include it. Then multiplied by CO2, coefficient 1, we don't need to include it. And then divided by CO, and then lastly H2O. Now that is equal to 4. And now all we need to do really is do some calculations here. Now let's go back to our table. We don't know anything about the equilibrium value yet, but we can start filling in the change. Now they haven't told us what it changes by, but we can always use X, right? Now since CO and H2O are reactants, they're going to be used up. So their change is going to be negative. So the change is going to be minus X. And since the ratio is all 1 to 1 to 1, H2O is also going to decrease by minus X. CO2 and H2 are products. So products will increase as the reaction progresses. So they're going to increase by plus X, and H2 will increase by plus X. That means at equilibrium, we're going to have 0,6 minus X. Here is going to be 0,6 minus X. Here is going to be 0,1 plus X. And then here is going to be 0,1 plus X. Don't forget, this is moles. Right? Now, for Kc, we need concentration. And so we can add one more column, or one more row rather, which would be our concentration row. So if we want the concentration here, we just divide by 2. So each one is going to be divided by 2. 0,6 minus X divided by 2. Here 0,6 minus X divided by 2. 0,1 plus X divided by 2. 0,1 plus X divided by 2. Now we have all the concentrations. In terms of X, we can substitute it in to our Kc formula. So here we're going to have 0,1, let's use a round bracket rather, 0,1 plus X divided by 2, 0,1 plus X divided by 2, and here 0,6 minus X divided by 2 multiplied by 0,6 minus X divided by 2. And now you can substitute this in your calculator and solve for X. So X will give you 0,37, and this represents the change. So this X value right here is these X values right here. Now remember, the question is asking us to calculate the mass of CO present in the flask at equilibrium. So if we focus on CO, so here's CO, this is the initial, this is how much it changed by, this is the equilibrium moles. So to calculate the equilibrium moles, we can say it's going to be the equilibrium moles is going to be 0,6 minus 0,37, and that is equal to 0,23 moles of CO at equilibrium. But the question is asking to calculate the mass of CO. Now, if we have the number of moles, we can calculate the mass. Remember, number of moles is equal to mass divided by molar mass. We got the number of moles, 0,23, is equal to the mass, that's what we want, and the molar mass is what we get from the periodic table. The molar mass is going to be 28. Now cross multiply, we get a mass of 6,44 grams of CO at equilibrium. Okay, and that's it. 9 marks, not too bad if we break it down into steps here. And I hope you found this useful. If you did, please leave a like, share, subscribe, hit that bell icon. If there's something specific you'd like me to do, specific question you want to ask, feel free to ask in the comment section below. And I'll see you in the next one. Bye-bye.